All right, we're going to talk about lesson 7 today. This is all about solving proportions. So first of all, we need to know what a proportion is. A proportion is a comparison between two ratios. And we use cross products to solve. So what I mean by cross products is when you multiply to figure out if, first of all, a proportion is actually proportional, or if you are trying to find a missing part of a proportion to make sure that it is proportional, we multiply diagonally. Or when we're done multiplying, it looks kind of like an X or a cross. So what we do is we go B times C and A times D. If this is true, if these two multiplied together is the exact same answer as these two multiplied together, it is proportional. If one of these is missing, we can solve this equation to find out the missing part. So, for example, in example 1, I have C over 36 divided by 9 or equals 9 over 15. If I do the cross products, we're going to be looking at this. So C times 15 is 15C, and 9 times 36 is going to get 324. I want to find out what this missing piece would be in order to make this an actual proportion, to make these proportional. So I divide by 15 to get C all by itself, and I would see that C is equal to 21.6. So 21.6 is what fits in place of or substitutes in for C in order to make this proportion true. In example 2, I have 16 over V equals 4.8 over 1.5. So again, I'm going to use cross product. So I have 4.8 times V, and 16 times 1.5 is 24. If I do 24 divided by 4.8, I get V equals 5. Now, we can also use proportions to solve word problems or real-life information. So, in this one, it says, an architect builds a model of a building before the actual building is built. The model is 8 inches tall, and the actual building will be 22 feet tall. The model is 20 inches wide, so we want to find the actual width of the building. Remember, proportion is a comparison between two ratios. So when we write a proportion, we want to make sure that similar parts deal with similar things. So for example, we might want to look at height of the model divided by width of the model is equal to the ratio for the height of the building to the width of the building. So again, this right here is the model. This right here is the actual building. If I start fitting in my numbers, so the model is 8 inches tall, so I'm going to put 8 here. It says the actual building will be 22 feet tall. It's okay that units are not the same because the units in the ratio will be the same. It says the model is 20 inches wide, so we're going to put the width of the model here, and this is what I'm still looking for, the width of the building. So I will do cross products here. So 20 times 22 is 440, and 8 times W is 8W. To get W all by itself, I divide both sides by 8, and I would see that W is 55. which means that the building will be 55 feet wide. Now, we can also use the constant of proportionality. Remember, the constant of proportionality deals with the simplified ratio all the way down to a unit rate. So keep that in mind. So it says a serving of 4 crackers contains 70 calories. How many calories are in 7 crackers? First of all, I want to look at how many calories per cracker. So I know that there are 70 calories in 4 crackers. I want to find out how many calories are in 7 crackers. Again, constant of proportionality would be this as a unit rate. But I'm going to use this as a proportion and solve it that way. So I'm going to rewrite my proportion here. So 70 calories for 4 crackers equals how many calories for 7 crackers. Use cross product, so 4 times C is 4C, and 70 times 7 is 490. Now to get C all by itself, I want to divide both sides by 4. And if I do that, I will find out that the number of calories in 7 crackers is 122.5. So there are 122.5 calories in 7 crackers. A good way to double check this work here is if we use the constant of proportionality. So 70 divided by 4, that can simplify all the way down to, as a unit rate, 17.5 over 1. So 17.5 calories per cracker. If I want to figure out the constant of proportionality for this one, they should be the same, but 122.5 divided by 7 as a unit rate is still going to be 17.5. So we did this correctly, which is good because we wanted to make sure how many calories were in 7 crackers. And if we were to get back to unit rates for both of them, we wanted them to be the same. And we did. So we checked our work, so this is good. If you have any questions, please let me know. Otherwise, this is the end of Lesson 7.